Hey everyone. Okay, so this is a continuation of section 4.5, and in this video we are only going to talk about parallel and perpendicular lines. Alright, so let's first talk about what parallel lines look like. Parallel lines look like these things, like they go in the same direction, they look like they never ever cross each other. Okay, I don't think any of these lines, even if they continue going out forever and ever, they'll never cross each other, okay? So parallel lines are two lines that never cross each other. They never ever intersect. All right, so I put these two lines on a coordinate grid so that you could see that they actually have the same slope. Let's count the slope of this line. So there's a dot here, and it looks like there's one right here. So this one has a slope of up 1, 2, and then to the right, 1, 2, 3, 4, 5. So this one has a slope of 2/5. All right, so let's look at this one. There's a dot here, and it looks like there's one right here. So counting, we're going to go up 1, 2, and then to the right, 1, 2, 3, 4, 5. Okay, so parallel lines have the exact same slope, but what I want you to notice, and you need to look at this, is that they do have different y-intercepts, okay? So the exact same slope, but different y-intercepts. All right, now, here we have vertical lines. Now, clearly they have the exact same slope. Both of their slopes are undefined, but notice that there is no y-intercept here, okay? Notice neither one of them cross the y-axis. So vertical lines are a very specific case of parallel lines that have the exact same slope, but in this case, we would say that they have different x-intercepts, okay? That's the only time that we care about the x-intercept is whenever we're dealing with parallel vertical lines. All right, so these are just three pieces of information that are true about parallel lines, okay? First one says, parallel lines have the same slope and different y-intercepts. Totally a true statement. We just talked about that. Okay, it says that if your slope of the first line and the slope of the second line are the slopes of two parallel lines, then the slope of the first line has to equal the slope of the second line. And then the last one says parallel vertical lines have different x-intercepts. All right, so this problem says let's use slopes and y-intercepts to determine if the lines 3x minus 2y equals 6 and y equals 3/2 x plus 1 are parallel. All right, so our slope and our y-intercept are staring at us on this one. So let me blow this up just a little bit. So we've got y is equal to 3/2 x plus 1. So that means our slope is 3/2. And our y-intercept is 0, 1, right? That's what we get right there and right there, okay? All right. Now, this one, it's not staring at us, so we have to turn it into slope-intercept form. So I would subtract 3x from both sides, and I end up with negative 2y is equal to negative 3x plus 6. And then I would divide everything by negative 2. So I get that y is equal to positive 3/2 x minus 3. So that gives me a slope of 3/2. So notice this slope matches that slope. And our y-intercept on this one is 0, negative 3. So notice your y-intercepts are different, but our slopes are the same. So that means that, yes, these lines are parallel. All right, so let's take a look at this. Y equals negative 4 and y equals 3. Well, y equals negative 4 is a horizontal, let's just sketch a little rudimentary graph here. Y equals negative 4 is down here. Y equals 3 is up here. Notice they do have the same slope. Remember, their slopes are 0, but they also have different y-intercepts, so that means that they are also parallel. All right, let's take a look at this one. So x equals negative 2 and x equals negative 5. Again, I'm just going to sketch a quick graph of this. So x equals negative 2 is right here. It's a vertical line, crosses only the x-axis, and x equals negative 5 is over here. All right, so they both have undefined slopes, but in this case they have different x-intercepts, and that's the only time we care about that is when we have vertical lines, okay? So yes, same slope, different x-intercepts means that they are parallel. All right, so on this one it says, use slopes and y-intercepts to determine if the lines y equals 2x minus 3 and negative 6x plus 3y equals negative 9 are parallel. You may want to graph these lines. All right, so let's see here. We've got y is equal to 2x minus 3. We have a slope of 2 or 2 over 1. We have a y-intercept of 0, negative 3. Okay, so let's take a look at the next one. Negative 6x plus 3y equals negative 9. I would solve for y, so I would add 6x to both sides. And then I would divide everything by 3. So y is equal to 2x minus 3. Ah, look at that. We've got the exact same equation here. Oh, I don't need to write that. So we have a slope of 2 and we have a y-intercept of 0, negative 3. You know what that means? That means that they are the same line. So they are not parallel to each other. It's actually just one line because they have the same slope and same y-intercept. So if I were graphing this, I would go to negative 3 on the y-axis. Then I would go up 2, right 1. There's that line. And then if I were graphing this one, I would go to the same place. It just sits right there on top of it. So it actually is the exact same line. So we would not say that those are parallel. All right, now let's talk a little bit about perpendicular lines, okay? Perpendicular lines cross each other, but they cross each other very specifically in 90-degree angles. So all 4 of these angles right here are actually right angles. That's what perpendicular means. They cross to create right angles. Okay, this page, it took me just a second to kind of be like, what are they saying? But here's what they're saying. They are saying that perpendicular lines are in the same plane. By the same plane, they just mean on the same coordinate graph, and they form a right angle. Okay, that makes sense. If the slope of line 1 and the slope of line 2 are the slopes of 2 perpendicular lines, then when you multiply the 2 slopes together, you get negative 1. Now, I'm not going to expect you to multiply your slopes together, okay? What I do expect you to know is that the slope of one line is the opposite reciprocal of the other. Now, hang on, I'll explain that. So, let me write here. If 2 lines are perpendicular, then their slopes are opposite reciprocals of each other. And now let me show you an example of what I mean by opposite reciprocal. Okay, let's say that the first line has a slope of negative 3. Okay, now don't forget there's 2 things that have to change. First of all, Opposite means one of them will be positive, one of them will be negative. Reciprocal means you flip it over, okay? So make it a fraction and flip it over, okay? So if I want to know what the slope is of the line that is perpendicular to this one, I turn this into a fraction. And by the way, this upside down T with the right angle there in the corner, this is shorthand for perpendicular, okay? So the slope that is perpendicular would be, change the sign, so I'm going to have a positive slope. Notice this one's negative, so my perpendicular one will be positive, and then I flip this fraction over, bottom to top, top to bottom, okay? So 1/3. So it doesn't matter what your y-intercepts are with perpendicular lines, by the way. You don't care about your y-intercepts on this one. What you care about are the slopes, and they have to be opposite reciprocals. So one will be positive, one will be negative, and then reciprocals. Now, there is a special case that happens whenever we deal with vertical and horizontal lines. We'll talk about that in a second. But for now, if your slope is just a number, then the slope of the line that is perpendicular is the opposite reciprocal. Let's try that again. Let's do another example. All right, so if the slope of the line is positive 2/3, then the slope of the line that is perpendicular to it, remember, this is positive, so my new one will be negative, and you flip it over. Okay, and again, we don't care about the y-intercept. All right, let's look at this example. All right, so use the slopes to determine if the lines y equals negative 5x minus 4 and x minus 5y equals 5 are perpendicular. Okay, all right, so we've got y is equal to negative 5x minus 4. So my slope is staring at me. It's right there. So m is equal to negative 5. Now, we learned from the last page that the slope of the line that is perpendicular will be the opposite reciprocal. So because this is negative, I want my perpendicular slope to be positive, and then I flip this over. Remember, all whole numbers can be made into fractions by placing them over 1. All right, we don't have to write that because we like to write things in the most simplified form. But all whole numbers can be turned into fractions by placing them over 1. So my new slope of my perpendicular line would be positive 1/5. That's what I'm looking for. All right, so x minus 5y is equal to 5. Now, I've got to turn this into slope-intercept form so that my slope is looking at me, okay? So to get this in slope-intercept form, I would subtract x and then I would divide by negative 5. So I end up with y is equal to a negative divided by a negative is a positive. So I do have 1/5 x minus 1. Okay, so my slope is positive 1/5. So I would say, yes, these are perpendicular to each other. Yes, perpendicular. Because of the slopes. Notice this slope was negative 5. This one is positive 1/5, so it's opposite reciprocal, which makes it perpendicular. Again, we do not care about the y-intercept on perpendicular lines. All right, so let's take a look at this. Use the slopes to determine if 7x plus 2y equals 3 and 2x plus 7y equals 5 are perpendicular. Okay, so they're both written in standard form, which means I need to put them in slope-intercept form in order to know what their slopes are. So I would subtract 7x and then I would divide by 2. Everything gets divided by 2. So y is equal to negative 7 over 2x plus 3 over 2. So my slope here is negative 7 over 2. Now remember, if it's perpendicular, the slope will be opposite. So this one is negative. I want my perpendicular one to be positive, and I'll flip these guys over, okay? So I would end up with a positive 2/7. So let's look at this equation and see if that's what we end up with. Subtract 2x from both sides. And then divide by 7. So y is equal to negative 2/7 x plus 5/7. Now, 5/7. Okay, notice the slope of this one is negative 2/7. I swear I know how to write today. And what I was hoping for was positive 2/7. This is negative 2/7. So I would say no, these are not perpendicular to each other because I needed to have a positive slope. This one was negative, and I was hoping for the perpendicular to be a positive slope, and I ended up with a negative. So I would say no, these are not perpendicular to each other. All right, so that's it for parallel and perpendicular lines. Make sure that you send me any questions you might have, and have a great day.